So let us discuss the concept of reduced mass in this lecture. Okay. So what is the concept of reduced mass? So consider you have a massless rod and you attach two balls. Say this is ball number 1 and this is ball number 2. Say the mass of ball number 1 is m1 and the mass of ball number 2 is m2. So somewhere there is a center of mass. So consider the center of mass is here and consider the center of mass is at origin. So where I have placed the center of mass, the center of mass is at origin. Now, so the distance between the two rods, I mean two masses, the distance between the two masses, let it be r. Okay. So if the first mass m1, so this is the origin O, which is also our center of mass. So consider this is r. Then this will be r minus r. So now we know that know the radius vector with respect to origin for m1 and m2. So how to calculate center of mass? We know that center of mass can be calculated as multiply mass m1 with r1 and multiply mass m2 with its own distance from origin. So that is r minus r divided by m1 plus m2. Agreed? Now you already know that we have assumed that our center of mass is where our center of mass is actually at origin, that is at 0. So from here you can directly deduce that m1 into r1 plus m2 into r minus r is 0. Okay. So from here what I want to do is I want to write r oh, sorry, there will be no r1, there will be only r. Okay, so there will be r here and r here. So what will be r in terms of capital R? So the small r can be written in terms of capital R as m2r. So m2r divided by m1 plus m2. Okay, this much is clear. So what will be r minus r? So now r minus r in terms of capital R can be written as m1 r divided by m1 plus m2. Agreed? So this much is clear. Now the concept of reduced mass says that I want to convert this system into such a system whose mass is concentrated at one place. So instead of two ball m1 m2, I have a mass mu. So let me write it as mu. Agreed? And this mu is placed at a distance r. See what is capital R? Capital R is the distance between m1 and m2. So it is a relative distance between m1 and m2. So I now want this system number A, and I convert system number A into a system number B of single mass. And I want that my system number B is such that when I rotate system number 1 around the axis, then the total angular momentum of system number 1 when it is rotated by an angular velocity omega is same as the angular momentum of this system when I rotate it with the same angular velocity omega. Now question is, what will be this mass mu such that when this mu is placed from origin at a distance r, where r is the relative distance between two mass m1 and m2 in the two mass system, then what will be my mu? So what is happening? So the system A is getting converted into another system. System A is a two body system and system B is a one body system, and I want the angular momentum in both cases to be same when I rotate them with angular velocity omega. So this particular condition that I'm using somehow makes system A and B to be equivalent with each other. So system A and B are what? They are equivalent to each other. Now, so if this system rotates, so if system number A rotates about origin, what will be the angular momentum for system number A? The total angular momentum will be sum of the angular momentum of the two balls. So there will be a m1 r square omega. So this is angular momentum of first. So remember angular momentum from the chapter that we already did in our basic literature of classical mechanics. So remember that. So m2, this will be r minus r whole square into omega, must be equal to the angular momentum of system number B. So what is the angular momentum of system number B? It will be mu, that is the mass, into radius square into omega. Agreed? Now what I want is, I want you to solve this equation yourself, which is very easy to do. And then what you will find, you'll find this particular expression mu r square omega equals to, so use this value of r and r minus r here and you solve this equation yourself, and you'll get this as m1 m2 r square omega divided by m1 plus m2. Now please see that the r square omega is same both the side. Okay, so r square omega is same both side. So obviously we are left with only one thing, that mu equals to m1 m2 divided by m1 plus m2. So an amazing thing happened. The moment we converted a two body system into a one body system such that both the bodies will have such that both the bodies should have same angular momentum when rotated with an angular velocity omega, then this one body system must have a mass which is equal to product of two masses of the two body system divided by sum of the masses. Quite amazing, right? So when you convert a two body system into a one body system, then what will happen? You need to take the mass of one body system as the product of the masses of m1 and m2 divided by sum of m1 plus m2. Okay, so this is one example.